Welcome to Module 7. And in Module 7, we'll discuss the RCM input to asset management. So we had a chance to see that asset management is more than maintenance management, but this maintenance management, as discussed in the previous model, is also an important part of the asset management. So let's take a look at some concepts, new concept that we have in here. The first one is operational risk. So similar concept, the same concept of risk that we have, a combination of the frequency or occurrence of an unwanted event, equipment failure, and the severity of such failures on an asset failure based on risk matrix classification. Okay, so similar that we saw during the RCM, during the FEMEA model, that in the first day, we have a risk matrix classification for each issues concerning corrective maintenance or preventive maintenance that we have in as part of our asset management. Okay, that's very important to create a list of actions as well as prioritization all the actions that need to be implemented. Failure class is another classification of the failure based on impact. So you can have failure class A, B, C, and A is the class that causes a direct impact on system and life cycle costs. B, for example, can be the effects will happen after some hours, and you can manage such failures, and you have not direct impact, and so on. Okay, FRACAS, we already discussed a little bit about our failure report and critical analysis system, and the FRACAS is important, as we already discussed and demonstrated here during this training. That's a very important database, and that's get all the incidents, the failures, and also the issues and the equipment degradation detected by inspection and non-destructive tests. And then these FRACAS get all such information, and together with the maintenance schedule defined mostly in CMMS or SAP, we encompass the asset management database. Okay, performance assurance plan. So after to get all this information, we need to put it all together. And the plan, this performance assurance plan will have all preventive and reactive actions, corrective maintenance, let's say preventive maintenance and corrective maintenance, to support the asset performance achievement. Okay, the key performance factors is also part of asset management, and now is a very important issue that shows that integrates all the groups involved in asset performance high achievements, and that's very important to measure the improvement actions, the preventive actions, as well corrective action effect on system performance. And the advantage to have asset management and not only a maintenance system management is that we can see the effect of all the actions in physical asset performance and monitor that and follow up such performance. Okay, and of course RCM is the reliability centered maintenance is a reliability engineering method that we had this discussion during this model during the second day of the training applied to define the asset preventive maintenance task. So just a brief description about asset management story. So the first initiative to develop something related to asset management was the key performance program that was developed in UK between 2003 and 2007, and the focus was the asset integrity and was applied to offshore platforms. So the main concern here was the effect of possible major accident caused by aged asset, physical asset. So the integrity was the main issue. So some audits was carried out based in different criteria such as uh, leadership, inspection methods, and so on. And that was one of the first initiative. In our asset management and asset integrity training, we give detailed information about such programs and about also about the standards. Okay, that's just a brief introduction to know where all these asset management standards and asset integrity come from. Okay, the PAS 55 have two parts, part 1 and 2. The one is definition, the 2 is more about implementation. Was the first standard to apply to asset management for, and that was in 2004 and was defined for all type of assets. After that, we had the ISO 5000 standards. So we have the part 1 and 2, again, definition, implementation, and the ISO 55000 was applied and defined for physical assets, and that's more specific for our process plants. Okay, so I will not go in details about asset management here. Again, we have a specific training model to discussion about asset management where all the information about the standards are defined. So if you are interested, you can look on our website to about this online training. Okay, so let's understand the concept of asset management. So basically what we need to achieve is high performance. So it's necessary to monitor our performance of our physical assets. So whenever we detect some issues, some problems, some equipment deterioration, degradation, we will set up some actions and failure reports, or even if we have some equipment failure, we will start our FRACAS system. The important point that's the failure reports and the corrective actions need to be associated with some risk, operational risk analysis. The risk analysis is what we say, the operational risk analysis. For each failure reporting, we need to check the frequency and the consequence and the effect on the system of that such a failure brings to the system, and based on it, we need to propose some corrective actions. Why the operational risk assessment is important is because we have in a real process plant, we have several issues every day, and we need to have some prioritization about which action need to be take place first, and based on the criticality, and the risk assessment is very important to support such assessment, and that's is done qualitatively based on experience of the professional, of the technician and operators, supervisors and engineers, and give a fast answer about which are the prioritization. You can also, of course, carry out some quantitative analysis, but that takes very long time because you need to have all the historical data of the failure and reports to carry out some lifetime data analysis, and after that modeling in a run model. So that's take a long, but in a routine daily basis, the operational risk will be enough. So after to define the corrective action and define the priority of which are the most important corrective actions that need to take place first, we also need to take into account that in some cases we need to have some changes, redesign some equipment that the preventive maintenance will not solve the problem because the problem is in the design, and all of such issues. If it's corrective actions, preventive actions, or if we have a management change, a change in equipment, we need to have some cost benefit analysis, and then that is one of the most important assessment, because as I will demonstrate, will give a clear idea what are among the most critical issues defined here as a corrective actions or preventive actions, including all of them. Many of them will be in an intolerable level, and because of that, the cost benefits assessment will enable to describe which one in the intolerable level need to be, will bring the best cost benefit. The ones that bring the highest best the highest cost best benefit cost for the asset performance will be the one that we implement. And we have all such information in a plan. And of course, that's the advantage to have the asset management system, because the performance assurance plan encompasses all the issues related to maintenance, related to changing, and also related to some issues that are opportunity to improve and need to be considered. That will be everything in this performance plan that will be in line with the asset management strategic plan and performance achieved in a long period of time. And all manager will have access of that, and then in a high level that they can discussion and approve the budgets for this plan. Okay, this plan, the implementation of this plan will be linked to the, of course, the performance. So we implement this plan and monitor and measure the performance, the key performance index, and if we achieve the production targets, and follow up all the register, the actions that need to be implemented. And then we'll come again and keep monitoring the performance and try to detect new issues. Okay. By the other hands, we needed to have to mitigate the risk of the whole plan. And of course, when we come in this point, we already perform some operational risk analysis, and we already have the prioritization of this plan. The point is, every day comes out new issues, and this plan is dynamic. That's every day we'll go through this loop, get new issues here. This plan is updated, and in order to come here and minimize and reduce the risk. The other important issue that's when we have an asset management platform that is, and in this platform we have in a cloud that is online and have and all interested parts have access, is that they can learn by the problems that happen and the corrective action that they implemented and avoid that this failure repeats again and again in the same physical asset, in the same process plant, as well as in other physical assets, similar physical assets or other similar effects that can have the same issues. So that's enable organization learning from the point of view of performance achievement. Okay, and again, we need to check if we're really minimizing the risk and if people are learning, the organization are learning with the mistakes by monitoring the performance asset. Okay, let's take a look how looks like effective asset management concept and workflow. So as described in here, we have assurance activities that's dedicated to perform and monitoring the system performance. That's about this performance monitoring here. And whenever some issues happen, we need to report a failure. Okay, so in the first stage, this failure is reported by technician or operators, and then go to a supervisor level, engineers level, that's considering this failure report, also considering others failure that already happened, and it's time to make some risk assessment and for system and organize such information in order to have such information very organized by system, and they were able to look at the system as a whole as well as look on the group of equipment and components. And of course, need to be carried out some risk analysis, operational risk assessment that I will demonstrate in the next slides. And based on it, we have some actions prioritization. Okay, so let's go through this flow. If we need to it is needed to have some corrective actions. We go through corrective actions, we assess these corrective actions, and then these corrective actions go to assurance plan. If these failure reports are based on some inspection, again the inspection, the maintenance team will assess the risk and will put the information in some system that they already have. If they have, for example, the IBM Maximo, so this will be linked to this asset management solution, and then that will come everything to the assurance plan, and that will be constantly reviewed by the manager concerning the budget, that's the limits that are limits, and also the resource that they have, and then they can constantly update this assurance planning here. So what can also happen is in some cases we can detect some improvement opportunity. So this improvement opportunity mostly defined by technicians and operators, so they need to bring these issues to engineers. Engineers will discussion about that, and then they implement some actions. And again, there will be some discussion about that, and that will be part also of the assurance plan. The other important point is the integrity of the assets. So as long as we assess our risk and we identify there are some safety related issues, in other words, we have safety critical elements in our process plants, in our assets. These critical elements will be part of the safety management, and actually will be part of that is of will be part of asset integrity management. Okay, so we're not discussing too much about that. Again, if you want more discussion about asset integrity, we also provide an online training that's give detailed information how this flow works, and how we manage all the critical, the safety critical elements, and how here, for example, we have Swiss cheese diagram that you, as long as we input some information here and define such equipment as a safety critical element, that will be part of this Swiss cheese, and then we can enable and check if the operational risk is non-tolerable on our layer of protection analysis diagram, and then we can manage that. Okay, so these are the asset management flow. That's a proposal flow by the solution that we have so-called as Integrity Pro. Okay, but usually that's the basic flow that we have in asset management. Okay, so let's understand how is the link of the asset management with all involved parts. Okay, so of course we have some applications that are already in place. We have a maximum SAP Meridian, also soft. Some of them are restricted to maintenance group for to measure the predictive maintenance and integrate with online system. Others are related to schedules maintenance and have both schedules and predictive maintenance. Other have all their tasks and included the cost, and other have also asset management include all these issues. So the important point is need to integrate all this information, the system that are in place in process plants in order to enable all the parts to assess the information. That's one of the big issues that differentiate maintenance management from asset management. Asset management is not only about maintenance, but also about asset performance. And when you have a chance to have an asset management platform that is in a cloud, we are able to give access for the groups, maintenance groups, and also another groups. So we have information that come from the physical assets, the power plants, the platforms, and the FPSOs, and any kind of process plants. We need to link this information to or the one of the system, but need to be on the cloud as information. Okay. The point is, if we have different system, one system that's send information to the cloud, another system that needs to be that's only the maintenance group have access, the manager and the executives need to have access to two different systems and need to have the information. That's not the objective for this level of leadership in the organization. For this guy, they need to have a solution that gives an organized information and integrate all this other type of information in one. So maximum is supposed to be one of the solution. I said in this Integrity Pro as well. So the objective is the first to integrate all such information as demonstrated here in the flow. So for example, we have information that came from IBM as well. What the maintenance group are defined as a preventive maintenance schedule. Let's go all for the assurance plan, that is the asset management. So the asset management is a system that is in here, and then they are available for different groups, so such as technicians, supervisors. So when this guy is starting to make any kind of failure reports or schedule some maintenance, this such information go for asset manager platform such as Integrity Pro. And in the same platform, the manager and executive can look on it about the system performance, about the 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 assurance plan, and review that. So in the end, we have only one platform that all parts are able to check the data online, and whatever they will be able to have an access here and to check the information. Okay, that's very important. We have another groups that's working and they develop technical issues. They are developing life cycle cost assessment, reliability assessment. They, of course, they are based in some procedures, some standards. They also need to get this technical information, the solution that they have concerning reliability and maintenance, and be linked to the cloud and the asset management solution. So in the end, all parts involved will be linked to the same system and will have access to the same database that we can look on the same information and take faster decision. That's the main point, is what type of and level of information we have in our flow and in our asset management. Of course, that's a description flow, but the asset management by itself have another configuration. Let's give some examples. For example, in the asset assurance plan scheduling, we get some how the maintenance group or maintenance technician includes some information. So here is an example of inputs that we comes from the RCM. So it's turbine again that's have some routines to be have a visual checks, visual inspection, and that's need to be done for the operators. And whenever they see this a deterioration or degradation in equipment, they need to inform for a maintenance group. So that type of task can be is defined during the RCM, and that's a routine that you need to do at least one per week, and need to starting in this date, finishing this date, for being a system to be established. Okay, so that's the type of information that is included by the maintenance group, and then they get the information from the RCM analysis. Okay, so but again, we have different types of information that goes to asset management, and asset management again is not only about maintenance but also about other types of information. So another important visualization, when we have different teams working remotely and we need to discuss, for example, about some specific equipment, what happens, what helps to visualize such information is when we have the assets draw defined by zones and by tags. So we can identify exactly what equipment we are talking about and then go to the analysis. Okay, and then of course uh, take a look on the what was the issue, which are the real equipment that we're talking about, and review the FRACAS assessment. So here we have some issues that was raised in 24th of April 2007. The issue was crude oil booster pump failed to operate, so it's a corrective maintenance, so go direct to the FRACAS, and that's have an impact on operation. The material corrosion or damage, so that's the classification. The life cycle cost, the cost related to such damage was already assessed, and that's great. And here's some comments that the booster pump failed to operate. Again, is shut down. And here is the subsystem, and they are carrying out some risk analysis about that, and that will be shipped for supervisor and maintenance engineer in order to assess and reassess the risk and put in assurance plan. So that's kind of information that comes from FRACAS, but we have also information that comes from CMMS. Then we have CMMS work orders that are input to asset management system. So here, as described in our flow, we have an integrated solution that's the Integrity Pro. They integrate the input from the IBM Maximum to directly to our assurance plan. So let's show an example. So here is a work order that comes from Maximus, and that's come out directly in our C. So if I click on here in the integrity pro solution, I can see exactly what is the working order. Each working order is about. Okay, so yeah, we that's happened automatically since the Integrity Pro, uh, one of the asset management solutions, integrate with Maximus, and then we have automatically search information here. And if you again, if you want to get the information about each work order, we will going to click here and read that. The most important that's in the end, we have the information that come from IBM Maximus that are the scheduled maintenance defined by the maintenance group, as well as other groups such as safety and operation that trigger some corrective actions, some defined related to safety or operation, and that come everything to assurance plan. Let's take a look on a FRACAS, specifically failure report and corrective action system. So since we have an issue that can be a equipment failure or even a result of some inspection or non-destructive tests that detect some degradation in a specific equipment, we can raise a report about such failure. So here, automatically in the system, when we click on failure reports, that's this template will open. That will be a reference number that's generated automatically. You can define the responsible for the report, the technician or the operator. So the date will be updated automatically. And here they put some observation. So about what's the condition of the equipment, they check some crack in the engine case. So they can also evaluate the impact of such crack. They classify the type of the failure and define if there will be some production loss. They can define the method of detection, and also here we have failure modes and description. So the failure modes are, and then again, the female RCM are very important issue. Since the RCM is a very important tool for the schedule maintenance and inspection in assurance plan, the FIMEA is that important input for standardize the type of failure modes that we have, the type of detection that's going to have for each equipment and equipment components failure modes and the description. Okay, and then that's the first step. Here you can see that they forward such information and go to the second step, and the supervisor engineers will assess such assessment, how they classify based on risk metrics. If they agree, they move forward and validate such initial reports and go further in to define some corrective actions. Okay, so in the end, what's going to happen is we have a lot of items in our risk register. So, and with these different risk levels. So concerning, and here we can see the ones that impact on safety on people again. And then in this list, all non-tolerable risks, some of them with the same height, you can see 1, 2, 3, 4, 5, 6 in the same level. The main issue is is to define which are the priority when we have risk in the same level with the same value. In order to define the operational risk, we have this risk matrix classification. So the risk matrix depends on the component. We will have different risk matrix configuration, but of course, for each issues in the FRACAS that are raised in the FRACAS, we need to classify the occurrence, the frequency of occurrence, and the severity. And then based on it, here we have the severity, here we have the frequency of occurrence, and then we can assess some level of risk, and based on that we have this rank of risk that enable us to give some prioritization concerning risk. The most important thing that, as we realized before, that some of the risk will be in the same level, non-tolerable, as this one represented by red, and some of them have the same value, so 25 or 20 or 15. So the main question is how to define the most important one that's need to implement. That's the action need to be implemented in order to bring the best results and minimize the impact on the company. So the cost benefit that's defined for each one of the actions, corrective actions, will give this information. So we need to look on the non-tolerable risk concerning non-tolerable level that must be mitigated. The ones that have that brings the highest cost benefit. So if you look from the right to the left, you will see the ones that bring the highest cost benefits, and then we start to implement from the right to the left and bring the best cost benefit to the company. Okay, so that's the importance to have the cost benefits assessment in the FRACAS for each type of issue raised in the FRACAS, and in some cases as well for the scheduled maintenance, what type of failures they intend to prevent, and what's the criticality based in terms of risk. As we discussed before, asset management is not only about FRACAS as well as scheduled maintenance and preventive maintenance. It's also about performance. So as long as we are updating the FRACAS system with the failures and the equipment that are critical for business that have directly impacts in the system performance, automatically the system will generate the performance. And this one, for example, is related to oil production, so we can check the production efficiency achieved for each day, and in the end we have a cumulative one for each month and a cumulative one for the year. We have also automatic information that's based on the information that comes from the FRACAS that generate the production loss, the total risk during each month, and we can see for each month what happened in terms of non-tolerable risk, and if they are increasing, decreasing, or if they were mitigated. If we click on here in the integrity post solution, we can exactly know which are the risks, and of course the manager can easily follow up this graph. So the most important point here also we have different graphs. That's the trip buster or safety environmental related actions that need to be mitigated, and how many are delayed, how many are for the future. So that's an important tool for the manager, so that he can click on here and see which one are related for his team and managing his team activity in order to minimize such delay in terms of action. So asset management, as I mentioned before, platform will give online information, automatic information that's in all different levels of leadership in the company concerning directors, general managers, process plant managers, group leaders, and supervisors. They can assess also the performance of the plants and check how much their team's activity affect and delay it to mitigate and increase such performance and keep the system in high performance. Okay, and here we also have the online monitor, and then some solution like OZSoft, for example, that is applied for this predictive maintenance or online monitor, or even that we call health condition monitoring, are also integrated in the Integrity Pro in asset management solution. Then that's a tool for maintenance group, but also is in the system that everyone can check. And that's very important tool that can be used during a meeting. So if we need to have a meeting, we don't need to prepare again the slides and take time to collect information, because all information in the asset management platform. Okay, and another type of performance index are the league table of the bad actors that show the operation availability for each critical equipment in a month or in a year, and mostly in a month, and that's give a very valuable input for the assurance plan and the risk assessment, operational risk assessment for each action that needs to take place. So usually if these equipments, all of them are critical for and have direct impact on the system, the one that have lower operation availability, this one is in the top, and the one that needs to be improved in order to improve this whole system operability. So asset management is also about performance index, and the advantage and the big difference from asset management to maintenance management is that based on performance achieved, we can have a clear idea which are the actions that are enabled to improve our performance or keep our performance, our target achievement, and which one are need to be discussion to be improved. And another important information KPIs that we implementing in this type of solution is the reliability. So usually you need to have a special tool to predict reliability of some specific assets. So now what is implemented by the Integrity Pro, for example, as long as we have the FRACAS automatically generates the reliability PDF and plots, and then we can check if this reliability is achieved as requested based on what was defined in as a target for equipment. So that's very important for warranty terms. So we have one warranty performance based on warranty terms, and we need to check if this warranty is achieved for by the vendor. So in asset management, as long as we start to plot to input the FRACAS information, the system will generate such information. Then we have the reliability plots and reliability on time, and we can check if we are achieving the performance index or not. Another important information, especially for maintenance group, is the expected cumulative number of failure. That's also based on the FRACAS input information. The system generates that automatically, and that can predict the cumulative number of failures in the future, and that's enable to maintenance group take some decision and also check if they are here based on mean time between failure tendency, if their equipment are increasing or not. So here we can see that the mean time between failure are increasing. So that means that there will be some issues related to maintenance, or even is increasing. That means that the reliability is improving. If the mean time between failure is increasing along the time, that means that is the preventive maintenance is effective, the preventive actions or even replacement of some equipment or components are effective. That's increasing again the mean time between failures. So two index very important for a particular equipment. Three index reliability as well, that can support the decision and based on quantitative analysis. That usually is carried out by reliability engineers, but here in system it's defined automatically. Okay, so this overview about asset management is important because in many cases we only see the maintenance manager as the main activities to achieve performance, and of course the RCM is the main input for the first step to establish the maintenance strategy as well as the maintenance plan. But we see that first we need to link the RCM activities to our not only to the maintenance system such as CMMS or SAP, but this need to be linked to the asset management system, and we need a platform that integrates all this information concerning not only maintenance plan but also corrective action, safety issue, and so on, in order to enable to prioritize many of actions which will be the one that bring the best cost benefits in terms of performance achievement for a process plan. Okay, and that was the overview, the object of this topic. And if you have some issue or question, please send an email to me.